Hello friends, subscribers and new viewers of this channel, and welcome to Robotics and Mechatronics tutorials. In this tutorial we explain how to start with object-oriented and C++ programming in Arduino or ESP32 microcontrollers. In particular, we explain how to write an object-oriented code that will blink an external or internal LED on your Arduino. Although this problem might look simple, and you can definitely write a simple unstructured Arduino C code to solve this problem, by doing this exercise you will learn how to write a C++ class that will govern the blinking of the LED. The techniques that you will learn in this tutorial are very important for learning how to develop a disciplined and structured code that will help you to implement more complex projects. Here's the main motivation for creating this tutorial. I have noticed that online there are a number of individuals trying to teach Arduino or microcontroller programming. Most of the time they will teach students how to develop an unstructured C code where all the code will be placed inside a single Arduino source code file. This practice might work well for smaller projects. However, if you're dealing with a very complex project involving a number of actuators and sensors, this programming practice is ineffective and difficult to debug. It leads to long, cumbersome and difficult to understand code file. Moreover, the code cannot be used in other projects and all the coding time will be wasted. The correct strategy is to learn to write an object-oriented and modular code. This is exactly the purpose of this tutorial. The goal is to teach you how to write a disciplined and structured code that you can use in other projects. Not to obscure the main ideas with too many C++ coding details, we will use the simplest possible example and we will teach you the basic principles that you can apply in other projects. Okay, let's start with explanations. First, we explain the wiring diagram. In fact, you don't need to use an external LED or a circuit. All Arduino boards have an internal LED. This LED is referred to as LED underscore built-in in Arduino code, and we will explain this later on in this tutorial. However, if you want to go 1 mile further and if you want to reproduce everything that we explain in this video tutorial, then you can create this simple circuit. This circuit is very simple and it consists of an LED. Here it is. You can use almost any LED. Then over here we are using a 550 ohm resistor. By using this yellow wire, we connect this resistor to the digital pin 3 of our Arduino Mega. Then other side of the circuit is grounded. That's this white wire over here, and then this blue wire is connected to the Arduino ground. That is, we will send input signals to the pin 3. These input signals will be on or off, that is high voltage or low voltage. In fact, the high voltage will be, I think, 5 volts. Once the 5 volts is sent over here, we will close the circuit and the current will flow and it will light this diode. Then when we send low to this pin 3, or when we send 0 volts, the current will become 0 and this LED will not shine. Okay, let's start with Arduino coding. First of all, open Arduino and after that click on File, New Sketch to open a new sketch. In the sequel, I will explain how to write Arduino code that will turn on or off an internal LED on your board. That is, you don't need to build an external circuit to implement this code. Let's start. First of all, locate void setup function. This void setup function is called only once your Arduino is started or after you reset your Arduino. And this function is used to set up, or better to say configure, important things. Inside of this function, type this: pin mode LED built-in output. This name LED built-in is a reference to internal LED on your board. Namely, every board has an internal LED that's used for testing programs. And over here we are saying that we are going to send output voltages, that is, we will send voltages to this LED port. And that's it. Next, inside of this void loop that's infinitely executed while Arduino is running, we will turn on and turn off our LED. So let's learn how to do that. To turn on the LED, we need to use the function digital write. This is a built-in Arduino function that's used to send a digital signal to a specific port. And we need to specify the name of the port. In our case, the port name is LED built-in, and we need to say that we are sending high voltage. Then let's delay our code, for example, for 1000 milliseconds. 1000 milliseconds is actually 1 second, and let's then repeat digital write. However, this time we will send low signal. This high is actually either 5 volts or 3.3 volts depending on your board, and low is a low voltage that's approximately equal to 0 voltage. And after this, let's delay for another 1000 milliseconds, that is for 1 second. Next, let's save this file by pressing Ctrl S, and let's save it. The next step is to make sure that our board is properly connected. For that purpose, go to Tools, click on Board, find your board. In my case, it's Arduino Mega. Then click again on Tools, click on Port, and select the communication port. Then click here to locally compile the code to make sure there are no errors, and let's upload the code. Done compiling and uploading, and over here you can see that an internal LED on your board will be turned on and off. So we can change the code to make sure that it's actually working by changing over here the numbers. Let's do 3000 milliseconds, and let's see what will happen. Now the period will be 3 seconds, and that's it. Next, we explain how to write Arduino code that will turn on or off an external LED. For that purpose, you need to build a circuit that I previously explained. Let's start. Let's open a new sketch. And the first step is to define the Arduino pin to which our circuit is connected. In my case, it's pin number 3. Consequently, over here, I will declare and define a variable called LED pin, and I will assign the value 3 to this variable. Then, in this setup function, again, I need to say to Arduino that I want to send output voltages to this pin. So I need to type pin mode, then LED pin, and over here I need to say that I'm sending output voltages, and that's it. Good. Next, in our loop function, we need to again do digital write. Then we need to specify the pin, it's LED pin, and then we need to specify high. Then let's do delay of 1000 seconds. Then let's send low. Then again, let's delay for 1000 seconds, and that's it. Let's save this code. And let's first locally verify that the code is okay. There are no errors over here. Then let's make sure that the board is selected. and that the communication port is selected, and we can upload the code. And now your external LED should blink on and off. And that's it. Now we are done with the classical C-based Arduino programming. And in the sequel, we explain how to write an object-oriented and structured C++ code that will perform the same task. For that purpose, let's open a new sketch. And let's save this sketch by pressing Ctrl S, and let's save it. Here it is. The first step is to write a header file for our class. To do that, click here and click on New tab. And over here, let's name the file. I will name the file as blink class, and I will specify .h. Here it is. Now, whenever you define a header file in C++ or C, it's very important to include the guards. The guards are defined like this. If not defined, it's abbreviated like this, then you specify with capital letters blink class. Usually this name should match the name of your class. Only the letters will be capitalized, and then you do underscored and h. Then you type define blink class underscore h. And after that, you need to do and if. These guards are used to make sure that if you include several times blink class.h in your code, the class will not be redefined. That is, if you include once this file in any other file, then next time you type include, the file will not be include, that is, the class will not be redefined. Now, whenever you want to use Arduino functions such as digital write, delay, etc., you need to actually include Arduino header file. That is, you need to type this. In your previous code, you didn't include Arduino.header file since in this sketch over here, Arduino header file is automatically included. However, whenever you define your own class or your own implementation, you need to include Arduino H since you will be using the standard Arduino function. So let's define our class. Over here, we use the class keyword and we type blink class. And here it is. And over here, don't forget the semicolon. So let's define our public functions and private member variables. First of all, we need a constructor. So let's say again, the constructor should be named, the name of the constructor should be the same name as the name of your class. So let's type a blink class, and over here let's type unsigned integer pn and unsigned long period. What are these two variables? First of all, pn is the pin number and period is the delay period for blinking. Consequently, over here you need to declare two private member variables where the data type should match this data type. So let's type unsigned int pin number, and let's type unsigned long delay period. Okay, here's our constructor. Later on, in a separate file, we will actually implement this constructor where pin number will be equal to pn and delay period will be equal to period. However, before we do that, let's complete our class definition. Over here, let's introduce a new function. I will call it init function. And this function will be used to set the pins. And finally, let's define the function for blinking. I will call it blink LED. And here it is. Let's double check our class. First of all, make sure that we have guards, we have them. Then make sure that you included Arduino.h file such that we can actually use Arduino built-in functions. Here's the class definition, Blink class, public, private. We have the constructor, the function for initializing, function for blinking, and the private member variables. That's it. Let's save this file. Next, let's write the implementation file of this class. Click here and click on New tab and type blink class. Make sure that this name is exactly the name as your header file. However, instead of the extension H, use CPP since we are writing a C++ file, and click OK. And over here, we will write the implementation of our class. First of all, we need to include our class, and you can see that Arduino automatically recognizes our header file. Here it is, blinkclass.h. First of all, let's implement our constructor. So you need to type blink class, and over here, let's click on the constructor. Let's make sure that the data types and the names are correct. So I will go back to this file and I'm going to copy this. Then what's happening inside? Let's see. First of all, let's see our private member variables. We have the pin number. So let's set pin number is equal to the input pin number. And over here, delay period is simply equal to period. And that's it. This is the implementation of our constructor. Next, let's implement init function. Okay, over here, we need to type blink class, and then let's select the init function. However, don't forget that it returns void. Over here, we need to use the built-in Arduino function. That function is pin mode, and then we need to say that pin mode is actually the stored pin mode, simply pin mode, and over here we need to specify that it's output. And don't forget the semicolon. The main question is, why we can use pin mode function? Well, if you go back to the blinkclass.h, you will notice over here that we included Arduino.h, and consequently we can use all the other Arduino functions in this file, mainly because we are also including blink class, and blink class is also including Arduino.h. And finally, let's implement the blinking function. The name of that function is blink LED. So let's type over here void blink, or actually first we need to write the name of the class, and the name of the function is blink LED. Here it is. So over here we write digital write, then over here we specify the pin number, and we specify high voltage, and that's it. Then what do we do over here? We type delay, we use the delay period, then after that we type digital write pin number low, and again we introduce delay. And that's it. Save this file, go back here and save the header file. However, before I continue, I have again to repeat this. We can use digital write and delay functions since we included blinkclass.h, and this header file includes Arduino.h, and consequently we have actually included Arduino.h file over here, so we can use all these built-in Arduino functions. Before we actually use this class in our main file, that is in our sketch file, it's very instructive to explain where these two files are stored. Namely, Arduino likes to store files in this folder. See users, then your username, then documents, and you'll find the Arduino folder. And over here in Arduino folder, you will find all of your sketches. And if I click here, here is the sketch folder, here is the main sketch file, and here is the header file and the implementation file. Good. Let's continue. Let's go back to Arduino. And over here, the first step is to include the header file of our class. So the header file is actually blink class. Here it is. Then, after doing this statement, you need to do several things. First of all, let's define our pin number. So I will again type unsigned int LED pin is equal to 3. Make sure that this declaration and data type matches the declaration inside of your constructor. By following this principle and this suggestion, which is actually very important, we need to define our delay as unsigned long, and I will call it delay n, and let's start with, for example, 500 milliseconds. Then after doing that, we need to create our object. That is our class object. So we need to type blink class. I will call it blink1. Then I'm passing to this constructor the pin number, and I'm simply passing over here the delay in milliseconds. And that's it. Let's save this file and let's continue. Now in the setup function, we just need to call blink1. That is, we are calling the method init function. This init function will be called only once our Arduino is started, or after you restart your Arduino. And let's see what will happen. If we go to implementation, this function will set the proper pin. This is very important. And over here, our loop function is super simple. We're simply going to type blink1 dot blink LED, and that's it. You can see how simplified the code is, and the code is much nicer and it's not cumbersome. Of course, I just explained the basic principle, and you can expand everything explained in this tutorial to more complex examples. For example, over here you can have a class for manipulating sensor reading, then you can have a PID control class, or you can have a class that will interface your code with robot operating system or with even Raspberry Pi. Next, let's try to locally compile this code by clicking here, and let's hope there are no errors. And there are no errors. We are very lucky, because usually when I code I always see errors, and you will most likely see errors. This means that you didn't properly type some commands that I wrote or my code, so spend some time debugging if you see an error. However, you shouldn't see an error if you just blindly follow this tutorial and if you correctly type. Okay, now we are ready to upload the code, but before we can upload the code, let's make sure that our board is properly selected. Click on Tools, Boards, find your board, and make sure that the communication port is properly being set. It is set. Let's save this and let's upload the code. And the code will produce blinking of your LED. Let's change this number, for example, to 3 seconds, that is to 3000 milliseconds. Let's verify and upload. And now the period of turning on and off our LED will be 3 seconds. And that's it. I hope that you like this video. If you like the videos I'm creating, please press the like and subscribe buttons, and see you in the next video tutorial.